Hello, good day everyone. Welcome to Sunky STEM Academy. This is the channel that gives you more insight on physics and chemistry. Though I have two channels on YouTube. The first one is Sunky Maths Academy, which is strictly for mathematics. The second one is Sunky STEM Academy, which is for physics and chemistry. So I'll be your physics tutor for today. And I'm here to introduce to you a topic in physics, which is fundamental units and dimensions. But before I start with this lesson, please, if you are new here, kindly hit the subscribe button now, turn on the bell notification to receive any update from this channel. And also, if you are a student preparing for WAHEC, JAM, NECO, GCSE, IGCSE, A-level examination, or any other international examination, this is the right place for you to be. So let's start. Fundamental units. What are fundamental units? Fundamental units are the standard units used to measure a fundamental physical quantities. Let me come back to that again. Fundamental units are the standard units used to measure a fundamental physical quantities. Do you get it? While dimensions are the powers of the fundamental quantities that are used to represent physical quantities. Now, there are three basic fundamental units that you need to note. The first one is the mass, denoted by capital letter M. Second one is the length, denoted by capital letter L. Third one is the time, denoted by capital letter T. Now, take note of something. You see this length can be breadth, can be height, can be distance, can be displacement, because all of them are measured in the same unit. So the unit of mass is in kilograms, while unit of length is in meters, and this is what? Seconds. So anytime you have a parameter and the unit is in meters, they can represent what? L, when you are stating their dimension. Do you understand that? All right, so let's take a few examples on this to show what we have said so far. Now, examples. Suppose I want to state the dimension of area. All right, and we know that area is what? Length times breadth. This is the formula for area. Area is length times what? Breadth. I told you that both length, breadth, distance, displacement, they are in the same what? Unit. So therefore, they will have the same symbol as their dimension. So that means length is what? L. Breadth will also be what? L. Do you get it? And don't forget law of indices. This is raised to the power of 1. This is also 1, right? So if I combine those two, that will give me L raised to the power of 2. So that means the dimension of area is simply what? L squared. So from this dimension, I can get the units. All right? So the units of area will now be, what is L? What's the unit of 1 L? M, which is meters. So you just place your 2. So the unit of area is what? M squared. Do you understand it? All right. So let's go to the second one. Suppose I want to state the dimension of volume. Volume is length times breadth times height. So the symbol for length is what? L. Breadth is also what? L. Height is also what? L. So this combines to give what? L cube. So the dimension of volume is what? L cube. So I can state the unit of volume will now be what is 1L? M. That's M cube. So once you get the dimension, you can get the unit. They are vice versa. Once you know the unit, you can also get the dimension. Do you understand? But I prefer you getting the dimension before the unit. That's the best way you can secure or you can understand this better. Okay. Now let's take two more examples. Take two more examples on this. So suppose I want to state the dimension of velocity. We know that velocity is displacement all over time. Displacement, because of the space, that's why I didn't. This is displacement over what? Time. So displacement is the same thing as saying what? Distance. But it's just that displacement is a vector quantity, distance is a what? Scalar quantity, but they are measured in the same unit. So which means that if I'm to put it in terms of dimension now, displacement is also going to be what? L. While time is what? Capital letter T. So don't forget, this is the same thing as what? Power of 1. According to law of indices, when you are moving this up, it's the same thing as this. So the dimension of velocity is L raised to the power of what? -1. So from there, I can get my unit. The unit will now go, what is L? M. What is the time? What is T? Seconds. So the unit of velocity is meter per second, which is ms raised to the power of what? -1. It's as simple as that. Let me take another one. Suppose I want to find the dimension of acceleration. Acceleration is increase in velocity over time taken, but here I neglect the initial velocity because it's going to be 0. Okay, so acceleration is mean as saying velocity over time or increase in velocity over time taken. Do you understand that? We are coming to all this. Don't worry, just relax. So if acceleration equals to this, don't forget you have gotten dimension of velocity already. Just replace. That will give you LT minus 1 and the time, which is still what? Capital letter what? T. So what I did here, I'm going to do the same thing here. This is also raised to the power of what? 1. So if I move that one up again, I should have what? LT minus 2. So I can get the unit. The unit will now be what? L is what? Meters, which is MT is seconds, ms minus 2. That is meter per second squared. So we get the dimension, we get the unit. So you can try this and drop your answer in the comment section. State the dimension of force. Force is mass times acceleration. So in short, is ma. So state the dimension and the unit of this one and drop your answer in the comment section. All right, so that is all I have for you today. Don't forget to like my video, share this video, subscribe to my channel, YouTube channel, follow me on TikTok page and Facebook page. I'll see you guys in next class. And also don't forget, please, if you are interested in online class for any exam, GCSE exam, A-level examination, any other international examination, or exam, we are always available. So you can send us a DM and we are going to see to that. And if you want to score A in physics, please just calm down, relax. This is the right place for you to be. Okay. So I'll see you guys in the next one. Bye for now. Thank you very much.